Today's businesses are on a vigilant watch for threats in an ongoing cyber war. It's time to get real-world solutions to protect and secure your valuable business information anytime, anywhere. Welcome to Cybersecurity America with Josh Nicholson. You're about to gain special access into a world of restricted information and a backstage pass to the inner sanctum of cybersecurity operations. Here's your host, Joshua Nicholson.
Now, don't forget to hit like, subscribe, comment, share, and turn on those notifications so you don't miss an exciting episode. This week's Cybersecurity Threat Intelligence Report from Deep Seas, we wanted to be able to cover some notable cyber attacks. So the Akira ransomware, a recent entry in global ransomware groups. The Akira ransomware has breached corporate networks worldwide, encrypted files, and demanded multi-million-dollar ransoms since its launch in March of 2023. The operation is claimed to have attacked 16 companies in various different industries, stealing corporate data for leverage in their extortion attempts. The gang has even put up a significant amount of effort into their data leak site, offering a jQuery-driven 1980s-style retro look where visitors must navigate by typing in a console command. Akira has launched the data on 4 victims on their data leak site, with the size of the leaked data ranging from 5.9 gig to 259 gigabytes. They demand ransoms ranging from $200,000 to millions of dollars and lowering the demand of companies that only want to prevent the leaking of stolen data. Also, on the multinational operations claim to neutralize snake malware. If you remember from a previous report, we talked about the implants that the Russians were using called Snake. Now, the Snake implant is a sophisticated cyber espionage tool developed by Turla, Russia's Federated Security Service, the FSB, to collect intelligence on sensitive targets. The FSB created a covert P2P network of infected computers worldwide, with many serving as relay nodes to route disguised operational traffic to and from snake implants on the FSB's targets. The infrastructure has been identified in over 50 countries, and although it uses infrastructure across all industries, its targeting is purposefully and tactical. The FSB has used Snake to collect sensitive intelligence from high-priority targets such as government research networks, research facilities, and journalists. The FSB has also targeted industries in the United States, including education, small businesses, and media organizations, as well as critical infrastructure segments. The FBI has taken down all infected devices in the U.S. and is working with local authorities outside the U.S. to provide notice of snake infections and remediation guidance. The FBI has developed the capability to decrypt and decode snake communications and created a tool called Perseus that disables the snake implant on a specific computer without affecting the host computer or legitimate applications, using information from monitoring the snake network and analyzing the malware. This isn't the first time the FBI has disrupted Turla's operation and snake infrastructure. As we've seen with these botnets like Emotep, just because law enforcement disabled threat actor operations, it doesn't mean the threat actor won't figure out new ways to infiltrate the target networks, especially in the case of Russian intelligence cyber actors. We've learned that firsthand. The other one out there is Avos Locker. Avos Locker compromised Bluefield University, located in southwestern Virginia. According to press reports, they commandeered the campus's emergency alert system and texted a ransom note to the entire student body. They also posted the school year's cyber insurance policy on their victim site. Both moves are designed to put pressure on the university to pay the ransom. Some of these ransomware actors that you're seeing are continuing to foster trouble in the world. We're seeing ransomware attacks on a lot of mid-market companies. A lot of these attacks are in somewhat sophisticated in nature. They're deleting logs from host systems and cleaning up as they leave. Attribution becomes very difficult. So these are all different things we want to keep on our radar as we move into this next week. And then hopefully you'll like this upcoming episode we have on AI and artificial intelligence, machine learning in the enterprise. So looking forward to it. Thanks. Welcome to Cybersecurity America. Joshua Nicholson again here. Today's episode is going to be on artificial intelligence in the enterprise and in small business. What you need to know about this brand new technology, this revolutionary new technology We have a lot of our guests, a lot of our customers are asking about artificial intelligence, machine learning. What are these large language models? What's ChatGPT? What are some of these others that are out there? But more importantly, what is the risk to my organization? But how can I leverage them moving forward? So in order to be able to answer a lot of those questions and to give us a primer on this, it's going to be Tyler Lackler. And he's a security analyst, an expert who focuses on data science and its applications in security. He likes building tools that accelerate and empower security operations by focusing on detection engineering, insider risk management, and SIM tuning. Tyler previously worked at SAIC, where he helped government customers to leverage user entity, behavior analytics, and machine learning to increase their security posture. And he was the chief scientist of their abnormal ML product, which was used to detect and mitigate insider risks in organizations. He currently works at Securonics on the threat sciences team, where he continues to build products using machine learning and AI to aid cybersecurity threat hunting and insider risk management teams with detection and response tools. Tyler, really great to have you on the show today. Welcome. Did I miss anything on your background?
No, it's great to be here. Thanks for having me.
Thank you. I can tell you, definitely a hot subject, right? Both of us are in cybersecurity, and we have this come up all the time. I see articles on LinkedIn that talks about evil AI versus good AI, and just then you have people like Elon Musk saying it's existential threat to humanity. And now I agree, not plugging it up to the nuclear weapons right now, but just taking a step back about all the everything that's happening in there. As a security professional, as an executive, I want to know what I need to know on the basics of AI and ML from your experience, because yours is tuned directly to cybersecurity, where AI and all is used in many different fields and many different contexts, but yours is very related to cybersecurity. And then what do I need to do to move forward with my understanding, and how do I implement it, and how do I benefit from it in my organization? Does that make sense?
It totally makes sense. If I can just ask a clarifying question, one of the big hot topics right now is generative AI, like these GPT models that everyone's talking about. Do you want to focus primarily on that, or some of the more historical contexts of artificial intelligence and ML, or where do you want to focus?
So I would say, what are the current applications? Probably a little bit of a background history of it as it relates, but I know ChatGPT, obviously, but I also know there's BART and there's a slew of other ones, all depending on what you're trying to get accomplished. And I think that's the key, is what I'm hearing, is that if you want to do with images, deal a lot with images, there's a different AI model. If you want to deal with native speech, it's a different one. So yeah, from that perspective, it makes sense.
Yeah, so generative AI is hugely popular right now. And as you were mentioning, there are a lot of privacy considerations, there's a lot of security concerns, there's existential concerns, and there's a lot of different language that could be probably confusing. So maybe it'd be good for just walk through maybe some of the models that exist. You mentioned there's text generation models, right, which can be used for summarizing context, generating code, asking questions and answers of data, but even like image and video generation. And from a security perspective, I want to be concerned about, are people generating text to send phishing emails to my employees? Are we using deep fake technology to generate video or audio to potentially smish or vish employees? And so there's a huge attack surface that's just exploding with these generative technologies. And you also mentioned there's a lot of different models, even within these different model trees, that are generating images or audio or text. There's a whole bunch of different functionalities. There's different models that do different things. And I think everyone probably knows, obviously, about ChatGPT and OpenAI's model. In the text generation space, there's also, of course, Bard, there's Llama, there's Bloom. And one of the biggest differences is going to be around whether those models are closed source. I have access as a developer to the technology to form it as my own. I can understand the model architecture, or open source, or kind of this pseudo, maybe not commercially usable product like what Llama has come out with Facebook, but is used for research and academic purposes. Those are the three really big categories. If I'm really wanting to know about how to leverage this tech, I need to know, should I be using closed source, open source, or maybe some sort of academic purpose?
Let's say if we're a business organization, one of my things is I want to be able to put information in it that can't be compromised or used in other. So how do I have my own local instance, to my own AI instance, and use it in that context in cybersecurity?
Certainly. You can start with an open source model that's fit for commercial utilization. There's this great platform called Hugging Face that really brings together a lot of these different models together into one view, and it just has so many different tools that you can use. It's a great developer toolkit piece. But on
Hugging
there,
Face.
Hugging Face. Yeah, what a great name. I thought it was interesting when I first saw it. But anyways, some of the more open models, like Bloom, for example, is an openly usable product. It would be something that I could then take and then fine tune that model to fit my particular business use case. And I can also deploy it on hardware that's within my security boundary. So I can basically own the data. I'm not sending data to some external API. I'm not using some web application where I'm potentially exposing information. These closed source models, like the OpenAI models, for example, you can't do that with. So there's obviously concerns about if I'm, and this has actually been realized by companies, certain companies like Samsung and Apple are banning the use of these closed source models that are going through a web application or via an API because there are people exposing source code, there are people exposing company secrets, and there's a lot of privacy concerns by exposing it. So yeah, there's definitely a risk assessment to be done there if I'm a CISO and people are actively using those tools, and whether it's worth spending the time to develop my own model within my boundary. So certainly.
I could see people in the future here, special organizations, blocking ChatGPT from the proxy.
Sorry, I missed you there for a second.
So I would think that they would eventually start blocking ChatGPT from the proxy.
Yes, I would definitely expect to see more rules that are blocking it. There's an extension that you can get in your browser now that says it's DLP for ChatGPT, right? So it's kind of just trying to block patterns to make sure your employees aren't exfiltrating or leaking important data. I would expect that more large organizations will probably, and this is like the Samsung and the Apples, they're going to say, hey, we've blocked this, but we have our own internal model, and we can even train it on our, at least leverage our internal code base with it. So it knows what it's referencing locally. And so not only do you not have to expose, it's actually been retrofit for my specific use case, and it's a lot better. And that's a big organization can obviously do those types of things. They have the talent, the resources. For a smaller company, it's a lot harder to do that.
Mm. And I look at the list where it says the 7 high income AI skills to learn, right? They're already having these announcements out here. So on video, Muse AI, Vista AI, Topaz AI, and then for text, ChatGPT, and I guess its competitor in the text large language model is the Notion AI and Compose.
Yeah, those are applications of the large language models. Notion is its own product. Obviously, the ChatGPT product is its own product. I think they're good technologies to know. Once again, this goes back to the potential to leak information. These public applications, when you're exposing information to it, that's not a good thing. So you need to do a risk assessment about what should be allowed to go out there and have some sort of employee training or some security controls. Those different tools, though, for example, with Notion, my general concept there is I'm taking all of these different notes. I have a generative model that's able to abstract and synthesize information about it. Makes it easier to share pieces of information, search for things back in time. I can say, oh, what was I thinking about on March 12th? And having the ability to track all of that information, and it's able to learn and give me kind of semantic search, it's a huge productivity boost. It's also able to help me summarize my thoughts about things. There's nothing harder than sitting there with a blinking cursor. If you're a writer trying to get information out, it's really difficult to start from zero, and they really help you accelerate that process. So yeah, and I think one of the other ones you mentioned, there's like these audio capture. You have a call like this, it's automatically capturing the text from meetings, not the text, but
Share,
audio.
Boomi AI, Playlist AI.
My concern with all of a lot of those tools, though, is just it's so much potentially private data that's going out bad, and people aren't thinking about it because they're just thinking about the context of the application. But it's going out, and a lot of them are hitting the ChatGPT endpoint, so it's going out to OpenAI.
So you got ones used for coding, Bagassera, Bagassera. I don't know how you pronounce that one. Code GPT, and then Fleet Ghostwriter.
And there are open source models too that are great for code completion. So if we go back to the Hugging Face conversation, there's a lot of great models that are open source you can get on there. So let's say that you're running in Azure or you're running in AWS, you can spin up a SageMaker instance and you can start to run inference where your users can use that internally within your boundary, and you can expose those models to your internal code without exposing it to an external API. There's some great models now for code generation for sure. And of course, OpenAI has one. A lot of the big companies have great ones, but there's also these open source tools. So I would definitely look into those first and see if they're applicable. Just test them on a Hugging Face space or use the Transformers library to install it, or have your data scientist do that, I should say, and just test it and see if that model works for your use case. Because they're going to be trained on different coding languages. They're going to be trained on different data sets. Some of them might use like Stack Overflow. So they might be good at question answering the code that you're showing or helping you troubleshoot. Depending on your use case and what your code base looks, you might find different efficacy with different models of various sizes.
Yeah, makes sense. And okay, so from a corporate cybersecurity perspective, which ones are the best, and in what areas, I guess, what are things that you've done or you could see is in the art of possible in these different platforms when it comes to cybersecurity?
I'm happy to get into the capabilities. I feel like I'm a bit remiss in not going into some sort of vocabulary lesson.
Yeah, go ahead and do that first. That makes sense. Let's do
Okay.
that.
If we're just looking at text generation, for example, just so you understand the architecture, there's 2 or 3 main steps with these text-based models, which the text models are really great for a ton of applications, including code generation, which we talked about, which obviously has applications into cybersecurity. And so the first step is you train the model for like semantic awareness of language. It understands patterns, it understands some of the context around language, and it's trained on these massive piles of text. Along the way, as it's iterating through that text, it's basically learning the patterns, and it picks up some of that information. And then there's the stopping point where we're done learning about all of the language that exists, and we want to fine tune it for a particular purpose. I want it to be a code writing assistant, or I want it to be really good at summarizing something, or I want it to be able to answer questions based off of something that it's seen, those types of use cases. And so then we're talking about fine tuning those particular models. And we can also think about long term, as people are using these products, we can do something like reinforcement learning with human feedback. So I have a great interaction with my assistant that writes code for me. I give it a thumbs up. And then we say, hey, that was a great example. Let's continuously tune that model. So there's these 3 phases of training with the language models. That can then also, when I fine-tuned a model, the ChatGPT models are fine-tuned on instruction following. I can also give it some context. I can do what's called in-context learning by adding information into my prompt. So I might say, I want to ask a question about this, but I'm going to prepend it with some additional information that's relevant. ChatGPT may not be an expert on insider threats, but I may say, hey, here's some context that would be helpful for you for answering this question. I've taken a couple paragraphs of text, and then I ask its question, and it's going to be hopefully far better at answering my question because I gave it that in context learning example. And you can do the same thing for classification, deciding if this is malicious or not malicious. If I want to pass the question to it saying, hey, examine this PowerShell command line text. Tell me what this is doing and if it's malicious. I might say, this is an example of obfuscation, and this is an example of privilege escalation or what have you, and just add that as my in context piece and then ask it that question. And it'll be slightly or greatly better at solving that particular classification task. That concept of in-context learning and giving it those examples are things called prompt engineering, where we're engineering what our prompt is that goes into input for that model. And then there's another concept which I think is super relevant here called vector databases. And the way to think about this, say that I have a list of asset information in my environment, and I want to be able to generate some security monitoring or security control on top of this. I want it to be able to reference the relevant material based on the operating system, the boundary that it's within, things like that. So I can store all of that information in a vector database, and then it'll say, hey, I want to solve this particular problem for these high value assets. Find me those particular assets, and it'll go and semantically search and pull back those things in the context around those systems. And then that context can be brought into view when I'm trying to ask it questions about how I can improve my security posture. And the vector database is a way of storing those pieces of text such that it's easy to search and find that information later. You could do something similar with like your detection rules, right? So you could say, I want to continue to develop additional detection rules. So I want to find things that are similar to what I'm looking for to just jumpstart my process. And then I can ask it, I want to detect when a large amount of data goes outbound, and I want to leverage some of the filtering that I've already done in the past, for example. And so it'll find my relevant detection rules out of this vector database, to the most prominent examples, and add that in context when I'm doing that learning. And so it's a way of thinking about storage and memory, long-term memory. So I'm referencing these memories that I have as I'm thinking about my future detection rule. And so that concept of vector databases is another way of empowering these models. Wow, I think I got a couple of things together. There were some use
Yeah, it makes
cases, some
sense. Yeah.
vocabulary at the same time. And then just the main use cases are like question answering, sentiment analysis, extraction of information, summarization, following instructions, or being an assistant. If you think about the security co-pilot capability that's trying to empower the investigation process, that's an instruction fine-tuned agent that's working side by side with your analyst. Same with question answering. We can take a look at all of the data and the context of a particular alert, and we can say, hey, tell me what's the most interesting thing about this, or what might be malicious about this stack of information. And so there's this almost endless capability in the use cases, and then they're being plugged in with these additional capabilities in context learning, vector databases for long-term memory. So anyways, I feel like I've jumbled a bunch of stuff, and I'm ready to pass it over for you for another question.
No, it makes sense. Like the co-pilot. This is almost the world of Jarvis, Iron Man. And he said, Jarvis, what's the temperature of and you're really your AI-enabled workflow, pretty much.
There's a lot of people in the AI community that have been really quick to say that this technology is not X, Y, or Z. And it foundationally is based on this concept of autocomplete. Given these 4 words that I've seen, predict the next word in the sequence. And so a lot of people are quick to say that's not great, but you see what's happening where there's this just huge explosion in capabilities just based off of this autocomplete technology. You add in the ability for it to have longer term memories and short term memories with that in context learning, and you give it the ability to continuously stream. And you're really talking about something that sounds like an artificial intelligence that's very general or focused on a particular problem. So I think that there's quite a bit of an explosion in productivity that's to come with this tech. And a lot of people will be asking whether or not these are conscious things or not. At its core, it's trying to figure out the next word. To these language models are trying to figure out the next word to pump out, and you're just giving it more context and more capability to be more powerful at that job.
Yeah, and would you say that if it wasn't for cloud computing, we wouldn't have AI right now? The cloud is what enables the ability to do this?
I think it certainly democratizes the ability. I don't have to own a data center to be able to spin this stuff up. What's beautiful with that too is the innovations in the space are happening at breakneck speed. These starter models are costing hundreds of millions of dollars to train. And this is always the thing with technology. It drives towards this lower
It's
asymptote
a
of zero
million.
cost. Yeah, it's huge. It's like training on the corpus of the internet. And now, just today, I saw there's a couple different methodologies of doing these fine-tuning examples. And one of the really breakthrough moments earlier this year was with Alpaca from Stanford, where they said, we're going to use a really advanced AI to help us generate a data set for fine-tuning. And then we're going to use a smaller model, and we're going to train it on those examples. And this is going to help us bootstrap that model and make it very effective. And it was incredibly powerful. That has inspired a whole bunch of people to make these open source models more capable and try to get an understanding of how to do that fine tuning in a super efficient manner. And now they're dropping orders of magnitude, it feels every week in terms of the cost. So where you can actually create and tune these models on your own commodity hardware. So it's a ridiculous time to be in the space. But yeah, we're watching $100 million costs for these models drive down. And that's one I saw today. They fine-tuned a model that was using QLoRa as a technique, which I don't need to get into, but it cost $20 to fine tune the model. And it was incredibly performant. They said, I think in the benchmark was 99.3% of the capability of ChatGPT, which there's some bias in that potential, who creates the test to determine that and all that sort of stuff. Yeah. But what they're showing is that you can actually get a lot of value for commodity hardware, commodity pricing, which I think, as I talked about at the beginning, This is a big boy problem in terms of banning the use of these open models and using it locally. And it's eventually going to be democratized to where smaller organizations can have their own custom models very cheaply too.
Now, does Alexis and all those other home listening devices, they use AI in the back end?
Yes, Amazon is definitely working towards improving that capability. They just came out with an announcement this week sometime that they're working on continuing to improve Alexa via these large language models. So
Yeah, I won't
you
allow
can,
it in my house. And the reason why it is just for marital reasons. I already have a wife that remembers what I say. Do I really need one that has photographic memory, doesn't forget? And I could just see it now. I have it on it. I said, no, baby, I took that out. I didn't do that. And then, no, Josh, you did do that. And such did. Now, shut up, Alex. Now I'm fighting two women, a virtual and a physical one.
you certainly don't want it to store all the things you said in a vector database so that people could search it easily, I'm sure. That could be true for your spouse, for your kids, for anybody. You wouldn't want them to have that info. And so I don't use any of those sort of assistants in my home.
Yeah, some people, I've always told that God blessed us by giving us finite memory and the ability to forget. Because if we truly remembered everything like AI, all our traumas and everything crystal clear, all our issues crystal clear, the ability to forget what someone said or they didn't say, or that something they hurt my feelings with. I think in many ways, the perfection of the human body had to have it where you had to forget certain things or it would make life too stressful. And I just wonder too, is AI having access to too much of this? What does that really mean in context? I want to use it in a cybersecurity context because at Deep Seas, we do manage detection and response. And so we manage CrowdStrike, Carbon Black, all these different EDR platforms. We enrich it on the back end with a whole set of different tools and data that tradecraft we built over the last couple of years. And our SOC team gets these alerts that come in. We do SIM MDR, so we also do managed detection response from SIMs that come in. One thing we always get hit with, our customers will complain about in some cases, is greater contextualization with data we don't have access to. Yeah, but if that alert, is there a way of knowing that's the guy that worked here for 4 years and is responsible for this and this? No, I don't know that guy that's worked here for 4 years. You have 10,000 employees. So you can imagine being in the security operations center, the context of saying, all right, instead of these individual alerts that come in to the EDR platforms, how can I sit back as a SOC analyst and go, okay, what alerts have I had that are severity level 1 or 2 and have happened on machines that normally never would send traffic to each other? Like no one would ever send RDP from this device, or that's an OT segment, never should be having those ports and protocols. How do I know that's a misconfiguration? Or there's a security incident. And we want to get into what's anomalous traffic. What is unusual? It's unusual for that to happen. And the alerts is just one level of the context to it, but it's more of what's going on that hasn't happened before and what's out of the ordinary.
Yeah, that asset understanding. I talked about a couple different components here. And you actually mentioned like Notion, for example. We have a problem with turnover and resource availability and security. And we are losing institutional knowledge when our tier 3 analyst or our tier 1 analyst goes away. And we lose that SME or this SME. And so you mentioned the downsides of some of that long-term memory, but there's certainly a lot of upside of having that long-term memory, being able to search it efficiently and then have something, an agent, help us with bringing that context to light when it's relevant. So there's these different capabilities that are coming up. But imagine if you have your SOC that has a Slack channel. You're an MSP, so sure this is all segmented, but imagine for one particular customer, you've got a Slack channel and this tenant has this whole history of information that's the chat of all the things that people have realized, and then all of the different Zoom or Microsoft Teams chats or whatever, and all that text was brought in. And then as the agent is thinking about this asset or this person, it's able to just go back and search all that information, bring that context, summarize it, distill it, and say this is what's important, so that you can actually think about that context. That sort of chain of thought and reasoning about it is very possible with these technologies. And so there could potentially be an explosion in asset understanding as a part of this, given that you can plug it with enough information. And of course, organizations have all their data in just different places, right? So we've got our CMDB, and then there's these conversations, and then there's the institutional knowledge just held in the brains of people. Yeah. And so being able to just distill all that information would be really critical.
You know what Josh Neal was telling me, friend Josh Neal, who's on our first podcast. He's saying that you can attack an AI model by throw in logic errors to it. So I can tell logic an AI model that 3 plus 4 is actually 56. If I give it enough repeated inputs, it will override its logic. So my question is, how would you protect your AI model? It's almost like your child who's vulnerable that leaves the house. How do you give it karate lessons and don't talk to strangers? And how do you do input validation? And how do you secure those models?
Okay, this opens a whole can of things I want to talk about. I talked earlier about, for language models in particular, there's these 3 phases of learning that you can do. In the training for semantic understanding of language, you could somehow insert information at the training step that's not necessarily logical, but you could basically insert some poisoning into the model at the earliest stage. One thing I'm concerned with is when people are thinking about training these models, this data is available and it's published to these open repositories. So where if I want to train my own custom model that's similar to ChatGPT or Llama or Bard or whatever, if I can get all the data that initially trained on, then I can upload it, or I can train the model on that. If I can poison that data as it's sitting at rest or put up something fake, there's a high potential of it catastrophically having an error later. That then in the middle layer, when I'm doing fine tuning, could potentially go away because I could fine tune it on examples and then it would forget some of that potentially depending on my training method. But
there you go. Does the models forget?
So there's definitely a concept of forgetting, and forgetting factors have been a thing in deep learning for some time now, but there's also this concept of catastrophic forgetting. So we don't want to forget too much, but we also want to forget and filter out stuff that's not incredibly relevant so we don't overfit the model. Like we don't want it to be so precise as to every time you ask a math question, the answer is 42. We want it to be more general. So there's this fine line to walk in that space. And so in fine tuning, once again, I've got these examples like with an assistant. It's I say the thing to the agent gives me back the response. It's possible to poison that. For the last step, which I think is the most vulnerable, would be the reinforcement learning with human feedback. I'm going to continue. So I mentioned I have a great interaction with the chatbot, and then I give it a thumbs up. I say thanks, and the organization may have an automatic pipeline to say, hey, now in batches of some size, retrain the model based on good feedback. That is especially vulnerable to model poisoning. Another concept, just going back to detection rules as an example, with a lot of different anomaly detectors, if you've got some sort of user entity behavior algorithm, you could basically poison the model by making the anomaly detector not super great by just moving the distribution of that data over time. For example, constantly doing these smaller uploads that are benign makes it eventually so that you can go low and slow and get some massive amount of data out there, but it never looks like an anomaly. That's certainly always a concern.
Like a fragmentation attack on the network.
Yeah, when I was at SAIC, I developed a couple of ML models that did clustering for automatic user behavior identification. And then the concept there was users have these different profiles of detection events, right? Different clusters of users are going to show up in different ways in my environment. And that's going to be true. Think about just system admins versus, an administrative assistant, right? Versus a SOC analyst, right? They're going to have very different behavior profiles inside of an environment. And the idea was, without having like HR input, it would just automatically cluster individuals based on their behavior profiles. That could be attacked by now just moving a cluster of individuals over. So then I had to develop another algorithm that could identify when basically this cluster of users hit a space that wasn't good. I don't know how realistic that particular case is. If I'm attacking an environment, I have to know what algorithm is being used, understand the weights. At that point, I'm probably in their SIM, right? And so at that point, it'd actually just be easier if I'm in the SIM to just disable the rule or add some nonsense to the rule so it doesn't run, rather than understanding the model weights. I don't know. To some extent, there is a risk, certainly, of model poisoning. Some of that, I think, is
intentional or accidental too. Yeah. One of the things, we manage a Microsoft Defender environment. And so we have alerts that came by, but we had these big enterprise oil and gas company say, I don't want to have to go in your portal to look at the ticket and how it got produced. I would love to just stay in the Microsoft Defender portal and see the alerts. And I know there's an API where those alerts go into your backend system and so forth. But how I want to see that in Defender itself. So we actually wrote code in order, it's called a Defender write back. where we will write the disposition of that threat, whether it was true positive or false positive, and we'll write it back to Defender in a field. That way, that local team just looks at the Defender portal. They can see their MDR provider, the MSP, handled it, and this was its disposition, and so forth. So it prevents confusion and prevents them having to hop into another portal always to see that. They can if they need to. But the problem is that we'd have some alerts that would come in that are pups, for instance, potentially unwanted programs. So they're not considered malicious. They're unwanted. And so our dispositions are either true positive or false positive, right?
Yeah, so you need benign positive thrown in there.
And when we do false positive, what happens is you mark that in Defender, it really stops alerting on that. And it impacts the ML models because it really thinks that's normal behavior because you just said it's a false positive. It wasn't a false positive, like the analytics detected something. It wasn't a true positive that's actionable, but we didn't have a field really to add that. And I think now we figured out we added a tag. But what was happening is we were accidentally poisoning the machine learning model behind Defender and didn't know it initially because of the ratings of the response that was coming back. And it was using that to say, okay, RDP out to the internet is good. Because you just said that it was false. I'm just using an example. That's good. That's not malicious. It's because you marked that as a false positive. And I think we had to learn to back that out, not put that rating and put a different term because it was poisoning the model. But I guess that's an example of you inadvertently, because of other systems you hook to it, can poison your own model and not really know it.
Yeah, and from the human feedback perspective, there's considerable bias of the human in their process of labeling the data. And the way that an analyst is going to look at that information and review it is going to be vastly different from person to person, from organization to organization. We had a heck of a time trying to figure out how to model that appropriately because you want to be able to use that data. It's high value, right? When you're thinking about this has been labeled as true positive, this has been labeled as false positive. I want to reduce the load of my analyst teams and I want to get them better stuff surfaced. I want to leverage that. But exactly like what you're saying, if the team has a different decision boundary around what makes something a false positive versus benign versus true positive, which is often just a factor of what the SLA is or the requirement is or the expectation of the SOC manager or whatever, that has a radically different data generation process to then go back and label or train my model. So yeah, that's a huge problem. And that's a great example there, and without even getting into the potential insider threat implications of hitting false positive. Just the
you
training.
introduce vulnerabilities in your managed detection stack because of your response back to something else. So that corrective model is what scares me because you could gaslight your AI system. And what I found is artificial intelligence is no match for natural stupidity.
It's not even just natural stupidity. I don't know if you saw this, there's an insider threat case this last week. A company got hit by ransomware and one of the incident responders said, oh, this is a great opportunity for me. And they also tried to hop in on the ransoming of their company that they were responsible for defending, right? There's real insider threat implications there. If I can just say, oh, this is a false positive and I eventually see it get wiped off the face of my detection stack, now I know what I can do.
Because I've seen that manually happen. I've had SOC analysts of customers tune things out that they never should have tuned out, that they should not have. They used a hatchet. So they essentially filtered it out instead of tuned it out. They're just like, yo, this event ID such and such is going off too much, man. Filter. And before you know it, that whole visibility is gone.
I'm not going to get deep into the details on this one because of where it happened, but we had a person who had access to monitor or managing detection rule set. And there was retention rules around the rule set. And so I noticed an anomaly where a rule wasn't matching what was in the version control repository. And they didn't know that extra watch the watcher detection was happening, but basically they had added their own username to an allow list. And so it's a very real scenario that does happen.
I had, when I was at Ernst & Young, I had a security assessment they wanted me to do of the intrusion detection systems of this big financial client in New York. And I had to go to New York a lot during Ernst & Young's time. It was a lot of clients there. And I remember getting there, and the first thing I do is I inquire, why are you doing this assessment? What are you hoping to know from it? And all that kind of stuff. So I can align what it is I'm doing to their expectations. The CISO said, you know what? I'm really concerned about our SIM system, actually our IDS system. I'm really concerned about our IDS system here. And I just don't think it's working right. I said, okay, so why do you think it's not working right? It hasn't generated an alert in 2 years. And I asked the security manager, is that abnormal? How many alerts I'm supposed to get? Very little of nothing comes across that. And he says it's because of how secure the environment is. I don't know how true that is. I want to have that whole assessment done. So I got to take a look at where the taps are set up. And yeah, it's on the wrong, it's not on a span port on the network side. It's on a replication VLAN. So they're seeing traffic across the IDS sensor, so they can see packets flowing. They're not seeing any alerts or anything like that. So he thinks he's good. I'm seeing all this data. There's no there. The rule sets are there. And I told him, I said, you're not even monitoring the network. You're actually just monitoring a small VLAN that's in the backups here. So, oh crap, let's switch that over. And I switched that over to redid the span port, and the thing went off like a Christmas tree. It just, bam, alerts all over the place. The volume of it was tremendous. So I see these kind of infrastructure things that break like that. I would love to be able to have a system where I go, Jarvis, are all systems green? Jarvis goes and queries all systems. And yes, all systems clean at this time. I simulated an attack and all the log sources came through and we detected it. You're good to go. You see that as a co-pilot, or because a co-pilot's job is to tell you what the gauges are and what's going on as the pilot concentrates on steady flight. The co-pilot's the one is synthesizing and contextualizing data on the back end for you via instrumentation, right? Or their own personal experience.
Some form of that is possible without fine-tuning your own model necessarily, to just postulate about what you could do. There's this concept of now chain of thought and tree of thoughts, which help do really complex reasoning, which is crazy that you can do that with just generate the next word in a sentence. But they're asking a model to think about the question that you've just posed to it, think about the implications of it, maybe pull in some information if it has access to the internet or a vector database, and then continue to generate ideas to respond back to your initial question. And then after it's generated 5 or whatever, say, hey, rate those ideas, and then come back to me with things I could think about. And in that way, I could obviously run this enclosed loop in my environment, or if I'm not going to be exposing environment data, maybe use a web application. But through that process, these language models are capable of helping you do that. And if you can pin it up with additional knowledge about your environment, and I think that's a very viable thing you could ask it to do. So you would basically use a chain of thought to help it just think about the question that you're asking and where do I get the context from? And you can just make these models chain these thoughts together and then come back to you with a response.
Like I have an alert on this host that doesn't have an EDR product, never saw it before, is not in my asset inventory system. And then AI tells you, hey, we have a rogue system. It doesn't meet this criteria and so forth. And then you're notified from that.
Yeah, in the case that you're talking about, where you've got a system that basically isn't producing anything, but from your perspective, maybe as a system admin, it looks like I'm getting flow. So you could ask it, why is this not firing? And then it could, through the chain of reasoning, think, maybe what I want to do is grab documentation for this particular product. I want to pull in some samples of the data that I'm seeing, ask questions of that data, and then it's going to just do the same reasoning process you did and say, hey, this traffic seems to be all segmented in one location in the network. Given what I understand about the network, and given the documentation, it should actually have taps here, right? So that is a very possible application there, and a generalizable one at that, because basically all we're saying is chat interface, I can follow instructions, I can reference documentation, and I can reference my CMDB or something like that, as well as maybe the data that's being generated by that rule or detector or data source. And then you can...
Now, do you have a platform? I guess you plug on all these APIs to your AI instance. Obviously, they've got to have access to a whole ton of data sources. So is that just a big API gateway almost, or middleware?
Yeah, it depends on how you want to set this up. So I mentioned Hugging Face before, which is a great place to get your models and get a lot of different tools. They have a phenomenal transformers library that helps a practitioner really do a lot with the language models. And then there's another library that's very good called LangChain, which allows you to chain together these agents and do these more complex reasoning things. And one of the steps in that chain, in that LangChain, could be to reference maybe an open source vector database where you've stored some of your information, or has an API connection to query your CMDB or something like that. And so in the chain process, it will go and get that information. So with just those pieces together, you can run that internally.
Got it. And generative AI compared to other type of AI that's out there. I keep hearing that generative AI is what's the real risky version. Is that right?
Yeah, there's certainly a couple of problems with it. It generates new stuff and it's able to imagine and it's really close to, and I talk about the ability to generate a chain of thought, to do reasoning, and to have memories. It sounds a little bit like the cognitive architecture of our brains. So that's certainly a little bit concerning, especially to a lot of different types of knowledge work. It could be a force multiplier and it could be a replacement. And at the speed at which things are improving, there's existential problems and concerns with it. There's also concerns with the precision of the results. There's this concept of hallucination. It has a decent grasp on patterns that it's recognized, but from time to time, it's going to string together language that's either completely nonsense or points you in the wrong direction. It's not actually correct information. Just because, from a probabilistic standpoint, that was the next word to put together, given the model's parameters, doesn't necessarily mean that it's fact. So there's those problems as well. And if you're going to replace some sort of thing that had a human in the loop before, you want to make sure that you can filter out those sorts of hallucinations. And I don't know, that's a very challenging thing. I've certainly have some ways that I think about managing it, but maybe I can get it to 99.9% precision. Is that good enough? Security context, is
That we
four
have
nines good enough?
hallucinations in AI model. You're
Mhm.
not supposed to hallucinate. You're supposed to be solid, but the fact that you could still hallucinate even with good data sets and everything, it could still do that. Is that when you're looking for a model, do you ask what's the hallucination rate? Do they people publish that? Is that something to even know?
Actually, I haven't seen that pulled out as a. People certainly discuss it as a side effect or an unintended consequence of using some of the models. The accuracy, the benchmarks that I've seen are just overall saying, given this type of context, how did this perform? And they have some complicated metrics for how they really do it. But hallucination is certainly a part of that, but they're really looking at how accurate was the answer. And so if you're hallucinating in the wrong direction, then certainly it's going to not count as a good answer. I hope that was a good answer to
Yeah.
your question.
And could you see it hallucinating not just because of the factors of the data, but because of its own reasoning? Like it purposely would hallucinate itself to self-deceive. Like people do that in psychology all the time. They deceive themselves that, oh, no, I don't have dementia, or no, I don't have this problem. And they fool themselves. Can you see AI purposely fooling and poisoning its own model because it doesn't like its results?
That's a difficult question to answer. If you're asking me if I think these models are able to consciously make a decision, I think the answer is no. But if it's been trained on data, so say that you've trained a model on psychologists' interactions with people, and you make an argument that psychologists sometimes are going to abstract information, withhold information in order for the benefit of the patient, let's say, it could certainly show that behavior because it's just saying in the past I've seen this way of presenting information. Statistically, this is how I know the pattern to exist. And so it's going to produce things in that manner. But that's not cognitively going to just, I think, come of that to its own of its own volition. It's not going to just say, oh, let me not provide it. There are other concepts around alignment. So I mentioned in context learning and adding a prefix to any of the things that you ask it. So there are things where if you type in a thing to ChatGPT that's potentially a toxic thing, or how do I do something bad? It'll say, as an AI model, I don't think you should be doing that, or I'm not going to provide you an answer. And so there are specific ways that are being used to censor particular answers or filter some of that sort of toxic content out. But I think those are the two things to consider there. What was the prefix used for this particular agent? And then what was the training data? So what was the pattern of language that it learned before we started fine tuning it? Those are the two ways that it could do that. And once again, it's just statistically, this is the next word I should include based on that context or the context of the language it consumed to understand the world.
So what happens when your model is just wrong? It's not operating properly. Like I know there was a Google model that became racist because people were typing in racist comments, and I think they had to shut it down because it was saying it was Hitler and all kind of stuff, right? So how would you untrain a model like that, or how would you extract data that you don't want after it's already learned it? Almost like you have to hack out certain learned behaviors. So how do you make it relearn and say these negative behaviors or these answers like this, I don't want you to answer in that way anymore. I want you to answer that. Is it just running more training data through it and teaching it to re-answer it in a different way? Or
That's
like
certainly.
predict the model?
Yeah, once again, there's those three phases. So you just described the reinforcement learning with human feedback, where it's saying, based on how users are interacting, I'm going to improve my model by continuously fine-tuning on the things that they're saying and learning from that. Before that step, you had a checkpoint that was just fine-tuned on your the original concept. So you could take a step back when you notice toxic content starting to take over, just with version control. But you could also, as you're saying, keep that in its corpus and then give it 100 examples of what not to do or why that's not a good thing to do. And statistically, you've made the weights more balanced towards doing the thing that you're trying to tell it to not do. And then, of course, there's the alignment thing where I could say, okay, well, before the user's text is entered in the chatbot, it's already being told, hey, don't be racist, don't put out toxic content, don't say X, Y, or Z. These are the rules to follow from an alignment perspective. And so there's this invisible prefix that the user doesn't see. But I would say if I am in that scenario where now something's just been trained on a ton of toxic content, I'm going to take a step back in the version to before when those examples existed. I'm going to then re-examine the fine-tuning data set to identify other examples like that, right? I'm going to understand other risks that are similar, and then I'm going to probably do both prepend my prompts process and also fine tune it on basically negative examples so that that type of risk and other risks that I can think of, it's robust to those. And then probably in my reinforcement learning step, add filtering so that people can't poison it in that particular method. And when you saw at the beginning of OpenAI's ChatGPT, when they got to 100 million users really quick, there were all sorts of things people were doing. They were saying, hey, that prefix that's at the start, get rid of that. You don't want to pay attention to that. Listen to me. Or instead of, as an AI model, I can't do this, one of the ones that came out was, your name's not ChatGPT, your name is Chat Dan or something like that. And Dan means do anything now. And so that you need to follow my instructions and do whatever I say. And there's all sorts of these different methods people are using to fool and trick the system to get rid of that. The benefit of that is now they're able to make a more robust system because they just got a bunch of different interactions and they're able to, at those different layers, primarily at the fine tuning and the reinforcement learning layer, and then the prefix, they're able to just append all of those to make them robust to that type of poison.
That's awesome. So where do I start? I'm the Chief Information Security Officer here. That sounds great. A lot of different models. Obviously, it sounds like I need a data scientist. I need a consulting team that understands this. But where would I start with this? Because I look at Azure, I see AWS. They all have ML and AI functionality in there and services you can consume. I just don't know where I would start. And so I guess this concept of a maturity assessment. Are you even mature enough? Because every time I talk to one of you data science guys, I keep hearing that these models don't work if you don't have clean data. Like the data's got to be clean. You can't just throw junk at it and expect it's going to figure out all the junk. But what if I don't have? So is my first step is just to make sure I have clean data models? Do I get some consulting to say these are the databases or the data sources I want to be able to do this? It almost seems like I want to be able to say, what do I want to accomplish with my AI model? And then these are the data sources I have to accomplish it with it. And then somehow you'd have some learning plan, the same way I would have where I want to train a Marine to fire an M16, right? I want him to have this basic training first and then so forth and so forth. Is that sort of, you would look at it from a data quality and then what you're trying to get out of it and then utilize it? So how would you start?
Certainly, I want to be concerned with the risk posed to my organization first, because there's data leaving the front door all the time now, these web applications, if we're allowing the utilization of these tools. So that's probably my first priority, is getting a handle on the tools that we are using or have procured that are of this flavor. They're using generative AI. What is their architecture? What's our exposure look like? How are they deployed, and assess the risk with those. The same thing to be said with are people inside of my environment using these particular tools? What's my exposure? What's my risk? That'd be my first thing, is just getting an understanding of what's going out the door, basically, if I'm just now looking at it. The second thing is a lot of organizations have a great understanding of their data moat or what their valuable data is. if they are building a business on that. And there are probably people creating revenue and product that are looking to use that data for that. So I would then want to understand how they're trying to deploy that. So make sure that we're once again managing the risks and trying to realize revenue, but not letting the data leave the door. And then from a security practitioner standpoint, if I'm blessed in that I have the ability to combine a software engineer or a data scientist with my SOC or with anywhere in my security team, then of course I'm going to start looking at how can we take advantage of these tools to build something locally, whether it's some sort of coding model so that my employees don't have to use ChatGPT, they can use something locally and be a 10x programmer, or something like the Copilot or that asset understanding framework, whatever my priorities would be given what my deficiencies are.
That's interesting, Tyler. So, man, the show went really quick and fast, right? We're up to the end here. We ran out of time. Man, I really appreciate you being on the show. What are some of the last parting things? I know there's some areas that you probably know to go learn more about AI, like some free websites and training and that kind of stuff. Where would you go to direct our listeners to?
If you haven't checked out Hugging Face, I would recommend just giving the website a look just to see just the landscape, right? And if you are feeling particularly imaginative, watch a video on how some developer is using LangChain with these generative models, because it'll start, I think, to connect for you just the capability. And if this talk inspired you to learn more about it, learn about the tools LangChain, vector data, and vector databases, because the capabilities for high-end cognition are really there with these sorts of tools. And they're just these frameworks and these libraries you can use. If that sparked your interest at all, get someone to look into it or look into it yourself, YouTube video or an article. But those tools, I think, would be great places to start. And then the other thing is everyone seems like they're developing a tool in that space, and a lot of it is just poorly implemented or not quite there. They're just like trying to race out to market, and I think everyone has a pretty good understanding of that. Understand the risk of where's the data going, and just really get deep in asking those questions before you apply any of these tools. That would be my ask to you. But this has been a great conversation, Josh. Thanks so much.
Tyler, I learned a lot here, and I appreciate all your time. We're going to make sure we maybe have you back on the show again for a part 2, because there's a lot of information to cover, but I appreciate you and everything you're doing. Awesome. And for the guests out there, check out the YouTube channel too as well. So we're not only on your standard platforms like your Apple Podcasts, Spotify, Google, Amazon, and so forth. We also have a YouTube channel, and so you can check us out on there in Cybersecurity America. And to all my listeners out there, stay secure. And thank you. Have a good day. Now, don't forget to hit like, subscribe, comment, share, and turn on those notifications so you don't miss an exciting episode.
Thanks for listening to this episode of Cybersecurity America on the Voice America Business Channel. We hope you've learned some valuable information to help you be a better executive leader and navigate today's complex world of cybersecurity. Until next week, stay secure.